In the previous lecture, we discussed exponential growth and decay. Exponential growth and decay. Growth and decay. Differential equation which models normally the exponential growth is basically dp by dt. It is proportional to some kp. Okay. Let me add. Okay. Now this growth, and after solving it, we usually we obtain p of t is equal to some initial some constant of integration times e raised power minus or plus. It depends on growth or decay. Sorry, here we have t. So it depends. It is growth or decay. If it is exponential growth, we have a positive sign here, and if there is a decay in some kind of population, then there must be a negative sign here. Okay. So this growth of any particular population is basically without any limitation. But when the population grows large, there are certain other parameters, certain other conditions which we need to incorporate in this model. For example, let me add the people. For example, in a spread of a disease, a contagious disease, a viral flu, for example, in a certain community. For example, in LUMS, there are total maybe 1,000 students, and infected person comes into the campus and start infecting other people. So there is a maximum limit for infection to be spread. There are only 1,000 students. So the growth rate at a certain time, when the maximum students has been infected, the growth rate will decrease in fact. So if there is a maximum possible capacity in a certain community, then this differential equation or this exponential growth model doesn't work adequately, doesn't work properly. So in that case, what we do, we can write this differential equation, in fact, dp by dt, or you can write it in this way, dp by dt divided by p is k. So this population growth rate is not constant always under certain conditions. Because sometimes an environment also exerts certain restrictions on a population to grow. In that case, we assume that this k is not a constant. It changes with the passage of time. So we assume that here this growth rate of the population is some function of p, and it means it depends on the population itself. So in that case, the general model for the population growth becomes dp by dt is equal to p times f of p. Now, what is this function? This is basically a generalization of the growth rate. In ideal conditions, which we can assume that this function, the kind of or the type of this function is that we assume that f of p is a linear function. linear function. If we assume that it is a linear function, then we can write this function in this form, maybe a p plus b, where a and b are some constants, where a and b, they belongs to r. They are some constant real numbers. Now, now this function also must satisfy, we must obtain the previous model if we assume that this function is this. So we put two conditions here, that f of p is 0 f of not f of p is 0, f of 0 is k. F of 0 is k, means when we have 0 here, this function becomes the constant, and we must obtain the similar previous model dp by dt is equal to p times if this gives us k, because here we have f of 0 and this gives us p, k times p again, the original model without any restriction. Now the second condition which we insert, we put on this function is that if there is a maximum population and we call it m, then maximum population f of m, it gives 0. What does it mean? If the maximum population has been infected, for example, which I gave you the example of viral flu in LUMS campus. If there are 1,000 people in the campus and all have been infected, then the growth rate will become 0, because there will be no more non-infected students who will be infected by that viral flu. So in that case, the growth rate will stop. Everybody will be infected. So this M is what? Is the maximum population. And it is usually called carrying capacity. So if we try to make a graph of this kind of function, then it would be like this. F of 0 is k, and this constant is k. We assume that. And here we have m, that it is maximum population. So then this function is linear. If it is linear, then it would be a straight line here. So this is basically the graph of f of p. This is a very elementary function which we can assume as f of p. We can assume other functions as well which are not linear, and those functions could be maybe a function of this kind, or a function of this kind, or any other function of kind. So we assume that this function f of p is linear, and we put these two conditions on this function, that when there is a 0 population, sorry, 0 infected people, then the rate is k, and when there are maximum people who have been infected, then the rate of infection would become 0. Now, if using these two conditions, if we try to find these two constants a and b, how can we find them? The function is f of p is what? It is a p plus b. Then using f of 0 is equal to k, it gives us k is equal to a times 0 plus b. It means b is equal to k. Now, the other condition, we use f of m is equal to 0. It gives us f of m. So it gives us 0. And here we have a times m plus, what is the value of b? It is k. So from here, what is the value of m? It is negative k divided by नेगेटिव आप कह सकते हैं अगर इसको b ही लिखें, so it is negative b divided by a in that case. So this is the value of m. So what we have to find here, we have to find the value of a, not m. So the value of a should be b उधर आके नेगेटिव हो जाएगा. So b की वैल्यू क्या है? b की वैल्यू है k. So we get k here and we have to find the value of a. So a is what? It is negative k divided by m. So this is your a and this is your b. So the function becomes f of p is equal to the value of a is negative k by m times p plus the value of b is k. So which can be written as k times 1 minus 1 over m times p. So this is the value of the function f of p. Now, if you have any question, you can ask me. Someone was trying to ask a question. Let me see in the chat window. So if this is the value of the function f of p, then that equation, which we are trying to generalize, this one, it becomes dp by dt is equal to k times p times 1 minus p by n. This, where m is the maximum population, or we call it carrying capacity, and k is the growth rate again. Or in general, we can write it dp by dt is equal to some constant a times, आप a ना लिखें, आप इसको कोई और लिख लें, maybe c 1 times p 1 minus c2 times p. ठीक है? So in general, we can write this equation now in this form, where c1 is a constant, which is k, and c2 is a constant, which is 1 over m. So this is called basically logistic equation. This is called logistic equation, and this equation predicts the growth of population with the limited resources or limited number of population in certain situations. So this is called logistic equation. Logistic growth equation, you can say. And it is dp by dt, in general, a times p 1 minus b times p, where a and b are some real numbers. And its solution is called logistic function. Now, if you have any question, you can ask me. So this equation also works in a certain situation. For example, if we want to grow bacteria in a certain container, and that container can hold only up to 100 bacteria, then or 1,000 bacteria, then there is some restriction. There will be some restriction on the growth of bacteria when the population of those bacteria increases. When it goes up to the maximum capacity of that container or some kind of room environment, some kind of environment, then the growth of bacteria will definitely change when the population of bacteria increases. When the maximum capacity of that container will be reached, or the carrying capacity, which can hold the maximum number of bacteria, then the growth will definitely decrease, and it will go towards zero when there will be 1,000 bacteria in that container. Similarly, this equation also works pretty well in a situation when there is a growth which is dependent on some other kind of resources. For example, food. So if we are providing daily a food which on which maximum 500 bacteria can survive, then the growth rate initially, when there is a less number of bacteria as compared to the food which we provide them daily, then the growth will definitely growth will be maximum. When the maximum capacity, that is when 500 bacteria will be there in that container where we provide food for 500 bacteria, then the growth definitely will decrease after, if the number of bacteria increases up to 600, 700, because the food for surviving of those bacteria is only for 500. So these kind of conditions, restrictions, if there are in the physical process or in some kind of growth model, then this equation works comparatively better than that basic equation which we discussed in the previous lecture. So if you have any question, you can ask me. Now we are going to do an example of this model, which is related to basically the epidemic spread. For example, suppose a student carrying a flu virus or a coronavirus, okay, coronavirus. So a student carrying a flu virus or a coronavirus returns to a isolated college campus. For example, in LUMS, some student returns to LUMS where there are 1,000 students already in LUMS. And keep in mind that the campus is isolated. Nobody can leave or enter into campus. Only one student, which is infected, he came back to campus. Now, it is assumed that the rate at which the virus spread is proportional not only to the number X of infected students, but also to the number of students not infected. We have already discussed epidemic spread model in I think, starting lectures. Now, we need to determine the number of infected students after 6 days. If it is further observed that after 4 days, 50 students have been infected. So what is this? If we assume that let X of t denotes the number of infected people, infected students. And total number of students are total students residing on the campus are basically what? 1,000. Okay. If there are X number of students who are infected, then number of students who are not infected are How much? Infected. Not infected, they are 1000 minus X. Now, the spread of that coronavirus, it is proportional to uh, infected as well as non-infected students. Means uh, we can write that dx by dt, it is proportional to k is a constant of proportionality and is proportional to the number of infected and number of non-infected students. Okay? The students which are not infected. We assume here that it is proportional to the product of infected and non-infected students. Okay. And initially, how many students have been entered into the campus? It is x of 0 is 1. Initially, uh, one student has come back to the campus with while carrying that infection. Now, another information in the model is given that after 6 days, so we need to compute how many students are infected after 6 days. Means we need to calculate x, which is the number of infected students after 6 days. We need to compute x of 6. Another information is given. If it is further observed that after 4 days, 50 people have been infected already. So we are also given x of 4 is equal to 50. So this is all the information we are given in that problem. Now, we do not know in this question, we do not know the value of k. What would be the value of k? Because in this problem, in this particular problem, the rate of infection is not given. Okay. The rate of spreading that infection. Now, we can compute k by using this given condition. Now, first we need to solve this differential equation. First, we need to solve it with unknown k. Okay, then we will use this condition to compute k, and then we can compute x of 6. Now, I hope you can solve this differential equation. It is basically it is separable differential equation, and we can write it 1 over x times 1000 minus x dx is equal to k times dt. Okay. Now we can use partial fractions to solve this differential equation. We need to use partial fractions. I hope you know what is partial fraction. Partial fractions. I hope you can do it. I'm leaving this thing to you as an exercise. You have to solve this differential equation, and you would get, after solving it, the solution is x of t is equal to 1000 divided by 1 plus 999 e raised power 1000 minus 1000 kt. So this is the solution of the given differential after using the initial condition. We have also used the initial condition in order to calculate the constant of integration C naught. Now, this K is unknown here. K is unknown here. Means the rate of spreading that disease. I told you that we will use that condition x of 4 is 50. Means after 4 days there are 50 infected students. Now, x of 4 is equal to 50 using this thing in this solution. X of 4 is 50. We take the value of t is equal to 4. And then t is 4 is also inserted here, e raised to power minus 1000 into 4, the value of t into k. Now, in this equation, the only unknown is k, which we can solve. We take this thing on this side and divide by 50 here, and after taking log and doing some algebra, we can find the value of k, which is k is 0.99. Try to verify it. K is 0. Approximately 0.99. Okay. Now inserting back the value of k here, what do you get? You get the solution now, complete solution with everything known. It is 1000 divided by 1 plus 999 e to the raised power negative. It is divided by 1000 as well. Okay. The value of k is that divided by 1000. 0.99 divided by 1000. So when we insert it here, 1000 cancelled, and we get 0.99 t. Okay. Now this is our solution. Now we can calculate the number of infected people after any number of days. So it is in that question, it is being asked that find the number of infected people after 6 days. So by inserting t is equal to 6, we can compute the number of infected people after 6 days. So when t is equal to 6, we can compute x of 6 is equal to 1000 divided by 1 plus 999 into e raised to power negative 0.99 into 6. I hope you can solve it using calculator. And after solving it, what do we get? It is 276 students. So after 6 days, 276 students will be infected. Now, you can also calculate after 10 days, after 15 days, after 20 days, or whatever the number of days, you can compute the number of infected people. I hope you get it. If you have any question, you can ask me. The graph of this kind of function is basically always of the kind हमने पहले इसका ग्राफ डिस्कस किया हुआ है. I hope you remember that. Direction fields में we discussed the logistic differential equations. The graph of this kind of function or this kind of differential equation is always of this kind because there are two critical points here. अब अगर आप इस differential equation में देखें तो critical points क्या हैं? Critical points, I hope you remember from the previous lecture. There are two critical points. One is p is equal to 0 and the other is p is equal to, we put this thing is equal to 0 and we solve it. Okay. By putting this right hand side is equal to 0, we obtain p is equal to 0 and the other point is what? 1 over b. Okay. 1 over b, which is basically, agar hum compare kare 1 over b, what was the value of b? It was 1 over m. by comparing with that differential equation. So it is m. 1 over b is 1 over m, then 1 over b is definitely n. So there are two critical points here. One is 0 and the second is m. Now 0 is what? It is the population, 0 population, and m is what? It is the maximum population. So maximum population in this case, with that example, is 1,000. There are only 1,000 students in a campus. So maximum students who may be infected, who might be infected with that coronavirus, will be 1,000 students. So if we draw the lines which we call them isoclines. Okay. So the graph of this kind of equation is that the infection starts with the 1, or you can say 0, and it grows up. Now, until here, until some middle time here, the infection, basically, it grows exponentially. It grows. Now, after that moment, it starts decreasing the growth rate, and it goes till the maximum population. So at this point, the growth rate is increasing. Now, after this moment, the growth rate will definitely decrease, and the infected students will reach up to the maximum capacity, which is the carrying capacity, or you can say the maximum number of students will be infected. So, which is 1,000 students. So, this kind of graph basically we have always for these kind of differential equations, which are logistic differential equations. Now, if you have any question, you can ask me. There are some questions in the chat window. Let me see it. How did we get x of t? How did we get k as well? In this question, in this example, we have to compute. What is the question? What is the problem, basically? Suppose a student carrying a coronavirus returns to an isolated college campus of 1,000 students. Okay. One student which has a coronavirus, he returned to the campus, LUMS. So already there are 1,000 students in LUMS. Okay. So that infected person, that infected student which came back to the campus, he started infected to other students. Okay. So now what we are interested to compute, we are interested to compute the number of infected students after certain days. Okay. So we assume that we let x of t denotes the number of infected students, okay, which are being infected day by day. So only one student came back with that virus, and definitely after few days or day by day, the infected students will increase. So we assume here, let x of t denotes the number of infected students. Now we are trying to convert, we are trying to transfer that problem into a mathematical model. So if we want to convert it into a mathematical model, we have to express it into some variables. So where t denotes the time, and x of t is the number of students after a certain time. So total number of students are 1,000. And if we assume that there are x of t infected students, then there are students who are not infected. Then not infected students are definitely 1,000 minus x. Now, we know that the rate of change of basically rate of infection of those students is basically what? Dx by dt, which is proportional to the infected students and also the non-infected students. Okay, so this differential equation has been constructed with the initial conditions that initially only one student came back to campus who started infecting other students, and now we have to compute how many infected students are there after 6 days. And also after 4 days, obviously we can count them how many students have been infected, we know that after 4 days, there are 50 students who have been infected. So, and now we are trying to find how many students will be infected after 6 days or 10 days. So we have all this information where K is unknown. We can use this information in order to compute the value of K, which is the rate of infection. So this is what we have done. We have used this condition to compute K after solving this differential equation. And then when we have the value of K, we just insert the T is equal to 6 here in this in the solution of this model, which is what? This is the solution of this model. Okay. After computing the value of K using this condition, we have this solution. Now, here we have T, which is time. So if we insert T is equal to 6, X of T is what? The number of infected students after 6 days. So we insert here 6 and we obtain the number of infected students after 6 days. Now, if you have any question, you can ask me. I repeated this because there are a couple of questions regarding the K and what? And the non-infected students, yes. Now, if you have any further questions, you can ask me. Okay, then. So this was basically all about the logistic growth. There are certain other problems which I have included in my notes. You can try them and you can find problems for practice in the book as well. In the books which I have been uploaded, you can search other problems from many other sources as well. I hope you know. Now, saving for retirement, let me clean these. Another example which we are going to discuss is saving for retirement. If a person is doing a job, a worker is doing a job in a certain organization, then he saves 5,000 a year and invest it in some bank. Okay, a worker, you can say, or an employee, worker saves 5,000 rupees, or you can say dollars per year, and invest it in some business, making 6% interest annually, or you can say yearly. How much will that worker have after 30 years? How much will he or she will have after 30 years? So it's a problem of continuous, you can say, interest, because if he saves 5,000 in the first year, after first year, because initially he has nothing. So initially he has no amount. After first year, he saves 5,000. He invested in some business, or he put it in a saving account in a bank, and he gives a bank returns him 6% interest annually. So how can we model this kind of problem So first we need to convert this problem. In order to convert this problem into a mathematical model, we need to decide, we need to express the variables. So we assume that y of t. Y of t is what? What we have to compute here? How much money will he or she have after 30 years? So we assume that let y of t is the money he or she has at at a certain time, at a certain after a certain number of years. So let y of t be the amount which he or she will have after a certain number of years. Okay, let y of t denotes the amount of money he or she will have after t years. So t is the time here. Okay. Initially, how much money does he or she have? It is y of 0 is 0. Okay. So 5,000 एक साल में वो बिजनेस में इन्वेस्ट करता है या बैंक में जमा कराता है. ठीक है. At an interest rate of 6%. So the rate of change of increasing his money is what? We can say that dy by dt is proportional to or is equal to the rate of interest, which is 0.06 times the original money which he has invested. So this is the model which describes that the money increases at the rate of 6% yearly. And what he saves in the first year, it is what, or in each year, how much money he saves, it is $5,000 or rupees. क्योंकि देखें ऑलरेडी जो मनी है वो y है, वो कितनी इंक्रीज हो रही है 6% के इंटरेस्ट से, लेकिन हर साल 5,000 उसमें इन्वेस्ट मजीद जो है वो सबमिट हो रहे हैं. So this term will give you the 6% interest on the money which is already there in that account, and this 5,000 will give you the money in each year he submit or invest in that business. ठीक है, जो कि वो बैंक में जमा कराता है हर साल 5,000. ये भी हमें मॉडल में इंक्लूड करना है. और जो ऑलरेडी मनी है दैट इज y of t which is already in that bank account, saving account or in some business, तो उस पे 6% इंटरेस्ट भी मिल जाए. ठीक है. So this is how the amount of money will change. The amount of money will change. It depends on two terms. This term basically gives the increase in the money with the interest rate 6% on the money which is already there in that business or in that account. Now 5,000 is also basically he's putting in that business or in that saving account in a bank. So basically we have this model, this differential equation, which describes this kind of situation or social process. हमने शुरू में जो मॉडलिंग की डेफिनेशन ली थी तो उसमें देखी थी, तो उसमें क्या हमने, what is the definition of modeling, mathematical modeling? Basically a differential equation which describes a physical or a social process. So basically there are many problems in which we discuss basically in our daily life, which we encounter in our daily life. We can use differential equations to model these kind of problems. Now, this is the differential equation along with the initial condition y at 0 is equal to 0. ठीक है. अगर इसमें थोड़ा सा हम सिचुएशन को चेंज कर दें कि there is you have certain amount of money, mean for example 1 million. आप 1 मिलियन अगर आप किसी बैंक अकाउंट में सेविंग अकाउंट में जमा करा देते हैं वन टाइम ओनली इनिशियली, ठीक है, और उसको आप फिक्स डिपॉजिट है फॉर एग्जांपल, आप उसमें कोई उस अकाउंट में कोई और अमाउंट जमा नहीं करवाते या उससे निकालते नहीं है और बैंक आपको सिर्फ 6% या 10% इंटरेस्ट देता है, तो इन दैट सिचुएशन द इनिशियल कंडीशन विल बी y at 0 is equal to that 1 million जो आप जमा कराते हैं इनिशियली, ठीक है। बाकी अगर उसमें आप कोई भी अमाउंट जमा नहीं करवाते या उसमें से निकालते नहीं, तो फिर आपके पास ये मॉडल आएगा, ठीक है। 6% इंटरेस्ट बनेगा आपका, dy by dt is equal to 6 into y, 5000 नहीं आएगा। इनिशियल कंडीशन क्या हो जाएगी, y at 0 is equal to 1 million rupees. So this model will describe this situation. We can change this model by changing the conditions. अगर हम ये कहते हैं कि initially, now tell me what this model describes as 0.1 y minus maybe 10 or 10,000, ठीक है, and y at 0 is 1 million. What does this model describes us? Anybody? Are there any questions? Sir, can you help us integrate 1 over x? Partial fraction से हो गई, growth plus death. नहीं, in this situation जो कि अभी हम डिस्कस कर रहे हैं इन्वेस्टमेंट पॉइंट ऑफ व्यू से। फाइक बिलाल, टॉक टू मी।
सर हर टी पे 10,000 रिमूव हो रहा है, लेकिन 10% ग्रोथ है पिछली जितनी भी अमाउंट है।
If you have invested 1 million in a saving account in certain bank, ठीक है, तो इनिशियली क्या है, 1 मिलियन इन्वेस्टमेंट है या सेविंग अकाउंट में जो आप डिपॉजिट कर रहे हो 1 मिलियन इनिशियली, बैंक आपको 10% इंटरेस्ट दे रहा है ईयरली, लेकिन ईयरली आप 10,000 रुपीज जो है वो उस अकाउंट से ईयरली निकाल भी रहे हैं। दिस इज व्हाट दिस मॉडल डिस्क्राइब्स अस। यू आर राइट, ठीक है। आई होप यू गेट इट। इफ यू हैव एनी क्वेश्चन, Ayman Salman is also right. The interest rate is 10% and we are withdrawing 10,000 in every year, because again it depends what unit of time you are using. अगर आप T को T which is time yearly, तो ये सारा मॉडल जो है वो ईयरली डिस्क्राइब होगा, क्योंकि बैंक्स में नॉर्मली इंटरेस्ट जो होता है वो ईयरली दिया जाता है। अब तो बाज बैंक्स में मंथली भी देते हैं, तो एवरीथिंग विल बी ईयरली और एनुअली। अगर टाइम को आप अस्यूम करें कि टाइम जो है वो मंथली है, तो एवरीथिंग विल बी ट्रीटेड एज मंथली। इट मीन्स के आप इनिशियल इन्वेस्टमेंट किसी भी सेविंग अकाउंट में 1 मिलियन कर रहे हैं, 10% आपको वो मंथली इंटरेस्ट दे रहे हैं और 10,000 आप बेसिकली उस अकाउंट में से विदड्रॉ कर रहे हैं एवरी मंथ, ठीक है। दिस इज व्हाट वी कॉल इट। अब अगर हम ये कहते हैं कि आप 10,000 उसमें डिपॉजिट कर रहे हैं हर मंथ, तो फिर यहाँ पे प्लस हो जाएगा। आई होप यू गेट इट। इफ यू हैव एनी क्वेश्चन यू कैन आस्क मी। अगर आपका कोई क्वेश्चन है तो देखें। अगर हम सिंपली देखें, अगर हम कोई अमाउंट इसमें से उस अकाउंट में से निकाल नहीं रहे, ठीक है। तो इस मॉडल ये मॉडल फिर क्या एक्सप्रेस कर रहा है? ये सिर्फ कॉन्टिन्यूस इंटरेस्ट को एक्सप्रेस कर रहा है कि आपने इनिशियल इन्वेस्टमेंट 1 मिलियन कर दी और 10% आपको बैंक अगर इंटरेस्ट दे रहा है तो आपकी अमाउंट जो है वो डेफिनेटली बढ़ती जाएगी ईयरली या मंथली, वॉट एवर द टाइम यूनिट यू आर यूजिंग। सो अगर हम इसको सॉल्व करें, इन जनरल इक्वेशन ये क्या होगी? dy by dt is equal to k times y along with y at 0 is some constant y0. So this is your basically the same population growth model which we discussed earlier. And I told you a one differential equation can be used to model several physical phenomena or several social processes. So यही equation जो है आपके पास क्या है, पॉपुलेशन ग्रोथ एंड डिके के लिए यूज हो रही है, यही इक्वेशन आपके पास कंटिन्यूस इंटरेस्ट के लिए यूज हो रही है, यही इक्वेशन आपके पास हीट ट्रांसफर के लिए यूज होगी, यही इक्वेशन एडवर्टाइजमेंट काइंड ऑफ एक्टिविटी के लिए यूज होगी, वो भी एग्जांपल हम करेंगे लेटर ऑन। तो अगर हम इसको सॉल्व करते हैं डिपेंडिंग, यहाँ पे देखें के हमेशा क्या होगा, पॉजिटिव होगा। क्यों? क्योंकि हमेशा आपका जो अकाउंट में जो अमाउंट है दैट विल इंक्रीज। तो क्यों? अगर कोई बैंक आपको यहाँ पे नेगेटिव रेट देगा तो वहां पे आप डेफिनेटली अपने पैसे जमा नहीं करवाएंगे कि आपकी जो पैसे हैं वो दिन ब दिन कम होते जाएं। सो दिस के मस्ट बी पॉजिटिव हियर। ठीक है। तो अगर हम इसको सॉल्व करें, आई होप यू नो इट कि हाउ टू सॉल्व इट। तो सोल्यूशन किस टाइप का होता है? यहाँ पे वाई नॉट आ जाएगा विच इज इनिशियल इन्वेस्टमेंट। लेट मी ऐड द पर्सन। Yeah, the initial and e raised power k times t. So this is the solution of this differential equation by after using this initial condition. So y naught is what? It is initial investment or initial amount which you deposit in that bank account or in some business. Initial investment. Okay. K is what? It is the interest rate. Okay. And this function basically describes the continuous interest. So you remember this function because when there are two parallel continuous interests, then we have to use this function of continuous interest in a differential equation to model that situation. फॉर एग्जाम्पल सीपी फंड, आपको शायद पता हो कि क्या होता है। किसी भी ऑर्गेनाइजेशन में ये दिया जाता है एम्प्लॉयज को। यहाँ पे मैंने इसकी एक एग्जाम्पल शायद ऐड की थी। हाँ, सीपी फंड एग्जाम्पल ये है, सेंट्रल प्रोविडेंट फंड। बेसिकली कोई भी ऑर्गेनाइजेशन अपने एम्प्लॉय को प्रोविडेंट फंड देती है at the time of retirement. For example, I'm doing job in LUMS and LUMS is giving me will give me a CP fund at my retirement. ये कैसे मैनेज होता है कि every month they deduct 4% of my salary. ठीक है। कोई भी ऑर्गेनाइजेशन उसके पैटर्न डिफरेंट हो सकता है, उनकी पॉलिसी डिफरेंट हो सकती है। 4 या 5% एम्प्लॉय की सैलरी में से डिडक्ट करते हैं और 4 या 5% जो है ऑर्गेनाइजेशन में लाती है, टोटल जो है वो उसका डबल हो जाता है। वो आपका जो प्रोविडेंट फंड है वो पर मंथ आपकी सैलरी से कट के तो आपके प्रोविडेंट फंड में ऐड हो जाता है। ठीक है। और फिर वो प्रोविडेंट फंड जो है वो ऑर्गेनाइजेशन इन्वेस्ट करती है उसको। ठीक है। और उससे प्रॉफिट भी आता है। सो आपका प्रोविडेंट फंड कैसे इंक्रीज होता है? इसमें बेसिकली दो इंटरेस्ट आ जाते हैं। एक तो वो जो ऑर्गेनाइजेशन इन मंथली आपके प्रोविडेंट फंड अकाउंट में जमा करा रही है। ठीक है। और दूसरा, जहां पे उसमें इन्वेस्टमेंट की है उस इन्वेस्टमेंट से उस प्रोविडेंट फंड पे प्रॉफिट भी आ रहा है आपको। तो उसमें आपके पास मंथली दो इंटरेस्ट इंक्लूड होते हैं। इस तरह फिर आफ्टर 25 ईयर जितनी भी जॉब होती है किसी एम्प्लॉय की, तो आफ्टर द टर्मिनेशन ऑफ दैट जॉब वो सीपी फंड उस एम्प्लॉय को दिया जाता है। आई होप यू गेट इट। इफ यू हैव एनी क्वेश्चन यू कैन आस्क मी। तो ये एक एग्जांपल मैंने ऐड की है। uh, इसमें ये है कि लेट एन ऑर्गेनाइजेशन और अ कंपनी gives a CP fund to its employee in rupees after 2 years. Each year, the account earns 5% interest by the bank. Yeah, by the business where that company invested your money. 5% आपका इंटरेस्ट आ रहा है। अगर बैंक में जमा कराया है तो बैंक में, अगर सेविंग अकाउंट में है तो उससे 5% इंटरेस्ट आ रहा है। अगर इन्वेस्ट किया है वो मनी तो उससे भी 5% इंटरेस्ट आ रहा है इन ईदर केस। फॉर एग्जाम्पल, अगर कंपनी आपका जो प्रोविडेंट फंड है पर मंथ आपके जो सेविंग अकाउंट है, आपका जो सीपी फंड है, सीपी फंड अकाउंट, दैट इज अ डिफरेंट अकाउंट, उसमें जमा करा रही ऑर्गेनाइजेशन also deposit 8% of your annual income in that account। ठीक है, एनुअली 8% आपकी इनकम जो है उस अकाउंट में कंपनी सब डिपॉजिट कर रही है, और उस अकाउंट में, बैंक अकाउंट में, सेविंग अकाउंट में, और बैंक आपको उस पर 5% इंटरेस्ट दे रहा है। सो देर आर टू इंटरेस्ट इन दैट, इन दिस सिचुएशन। द करंट annual income is 50,000 rupees, but it is increasing at a continuous rate of 4% per year। ठीक है, write an ordinary differential equation modeling this situation, how much money an employee would have in this CP fund after 20 years। तो हमने इस चीज को मॉडल करना है कि सीपी फंड उसका कैसे इंक्रीज हो रहा है, और 20 साल के बाद उसका एम्प्लॉय का सीपी फंड कितना होगा। ठीक है, तो दिस इज a very practical question which we need to solve here, saving or you can CP fund। देखिए, अभी हमने इससे जो प्रीवियस एग्जांपल थी, वो जब हम डिपॉजिट कर रहे हैं मनी, तो उसमें हमने क्या कहा था, when we are depositing or deposited money into a bank। ठीक है, तो उसमें हमने कंट्रीज इंटरेस्ट क्या देखा था, कि क्या था कि y is equal to y of t is equal to, here we have initial investment into exponential of kt, where k is the rate of increase। देखिए, अगर हम if we look at this question, तो let t represents a CP fund account balance of an employee, let y of t represents a CP fund account balance of an employee in a certain company or organization। ठीक है, after t years, after t years। So this is your of maybe y of t represents the CP fund account balance of an employee after t years, where t is the number of years। Each year accounts earns 5% interest by bank। ठीक है, अगर हम इसको यहां तक रखें तो क्या होगा, हर साल बैंक जो है उस अकाउंट में 5% इंटरेस्ट देता है। तो क्या हो जाएगा यहाँ पे, dy by dt is equal to 0.05y, 0.05y। ठीक है, यहां तक तो ठीक हो गया। फिर आगे क्या है, कि the organization deposit 8% of your annual income in that account and the current annual income is 50,000. ठीक है, 8% of annual deposit कितना हो रहा है? 8% of annual income, and your annual income is what? $50,000 or rupees, whatever you say. So 8% of 50,000 कितना है? कितना होगा ये? 4,000, $4,000. ये आपकी इन्वेस्टमेंट है ईच ईयर, 4,000 ईच ईयर डिपॉजिट हो रहा है आपके अकाउंट में बाय द ऑर्गेनाइजेशन एज अ सीपी फंड. एंड बट आपकी सैलरी जो है वो इंक्रीज हो रही है. आपकी सैलरी इनिशियली क्या थी? 50,000. ठीक है, सैलरी इंक्रीज हो रही है कितनी? 4%. दिस इज योर सैलरी. ठीक है, सैलरी increasing 4% a year. ठीक है, 4% a year. अगर देखें अब यहां पे, अगर हम इस चीज को देखें कि इनिशियल डिपॉजिट कितना है? 4,000. और क्या है इंक्रीज रेट? 4%. तो ये जो सिर्फ आपका सिचुएशन है, ये आपकी कहां से आएगी? ये इस कंटिन्यूस इंटरेस्ट से आएगी. ठीक है, इनिशियल इन्वेस्टमेंट क्या है? y इज इक्वल टू y ऑफ t इज इक्वल टू y नॉट इज व्हाट? 4,000 e टू द रेज पावर. सैलरी इंक्रीज किस रेट से हो रही है? 4%. तो यहां पे k की वैल्यू क्या हो जाएगी? 0.04 t. सो ये आपके पास एक इंटरेस्ट और आएगा. आपके पास ऑलरेडी ये है और ये कॉन्टिन्यूस इंटरेस्ट और आ जाएगा. ठीक है, अब ये वाला जो कॉन्टिन्यूस इंटरेस्ट है हम इसमें डिफरेंशियल इक्वेशन में ऐड करेंगे. ठीक है, नाउ एडिंग दिस थिंग, आप इसको 2 कह दें. ठीक है, और इसको आप 1 कह दें. ठीक है, एडिंग 2 in 1. ठीक है, or including this in 1. What do we get? We get dy by dt. dy by dt is equal to 0.05y plus this increase in your amount, 4,000 e to the raised power 0.04 t. ठीक है, with the initial investment what? क्योंकि पहले साल तो आपका कुछ भी नहीं होगा ना, तो यहाँ पे y at 0 is 0 हो जाएगा. ठीक है, so this is the mathematical model which represents the CP fund account balance after t years. So you have to solve this differential equation in order to compute CP fund account balance after a certain number of years. After 20 years, so after solving it, you just have to put t is equal to 20. अगर आपने 30 साल जॉब की है तो 30 साल बाद आपका CP fund कितना होगा? You can compute that thing by solving this differential equation. Now, what is this differential equation? This is basically, इसको आप उधर ले जाएं. This is a linear differential equation. Right hand side इसकी non-zero है यहाँ पे. ठीक है, after solving it, I hope you can solve it by using integrating factor. Linear differential equation solve करनी आती है आपको. So I hope you can solve it, and after solving it, you have to compute the constant of integration as well, and then you have to compute the CP fund account balance after 20 years. कि 20 years के बाद कितना CP fund उस employee का इकट्ठा हुआ होगा. I hope you get it. If you have any question, you can ask me. यहाँ पे मैंने I think solve नहीं किया इसको. हाँ, नहीं किया. You try to solve it. Next thing we are going to discuss is the Newton law of cooling, जो कि हमने पहले भी डिस्कस किया हुआ है, but now we are going to discuss that Newton law of cooling in detail. If if you have any question for this example, which is the CP fund account balance, you can ask me any question.
सर
जी बेटा.
सर मैंने पूछना था कि जो आपने किया सैलरी इंक्रीजिंग 4% ईच ईयर, राइट?
जी.
तो अब हमारा इसके अंदर जो 4,000 है वो भी तो चेंज होगा, बिकॉज अगर हमारी सैलरी 50,000 नहीं रहेगी तो उसका 8% भी 4,000 नहीं रहेगा, राइट?
Definitely, you are right. But here, what we
तो
have in this function, this is basically, this function describes the continuous interest with the initial investment. Why not? This is your initial investment, not the investment which increase each year. The increase in investment each year will give us this whole function. Okay? ये पहले साल 4,000 है, जब दूसरा साल आएगा तो उसमें जो इंक्रीज होगी वो ये फंक्शन डिटरमाइन करेगा और मल्टीप्लाई करके उसको इंक्रीज करेगा ऑटोमेटिकली. आई होप यू गेट इट.
ठीक है, और फिर हम इसके अंदर ऐड क्यों करें जो dy by dt फाइनल है?
देखिए
ठीक है,
आपके पास
इसके
ये,
अंदर हमें y रिप्लेस नहीं करना चाहिए?
दिस इज द डिफरेंशियल इक्वेशन विच डिस्क्राइब्स द इंटरेस्ट विच बैंक इज गिविंग टू योर अकाउंट. ठीक है, 5% आपकी मनी में वो ऐड कर रहा है, बैंक जो है आपको 5% इंटरेस्ट दे रहा है. वॉट एवर योर मनी इज, वाई इज द मनी विच इज ऑलरेडी इन दैट अकाउंट. ठीक है, अब इस मनी में हमने ये वाली मनी ऐड करनी है ना, ये अमाउंट ऐड करनी है, तब आपके पास जो ऑलरेडी अमाउंट होगी वो वाई ऑफ टी होगी.
से हमने ऐड क्यों करनी है? हम इसके अंदर y की जगह इस अमाउंट को रिप्लेस क्यों नहीं करेंगे? क्योंकि 5% इंटरेस्ट तो उस अमाउंट पे आ रहा है ना जो बैंक के अंदर है.
देखें आपके पास ये जो है वो ऑलरेडी सबमिटेड मनी है. मसलन आपने 1 मिलियन सबमिट कर दिया, उस पे बैंक आपको 5% दे रहा है, तो 1 मिलियन के पे जो है वो 5% क्या होगा, इंक्रीज होगा ना 1 मिलियन पे. लेकिन सेकेंड ईयर आपकी जो अमाउंट है उस 1 मिलियन में ये वाली ऐड हो जाएगी, ये अमाउंट. ठीक है, हमने ये अमाउंट ऐड कर दी. अब आपको जो आफ्टर 1 ईयर वाई होगा वो 1 मिलियन प्लस दिस अमाउंट, वो ऑलरेडी इसमें ऐड हो जाएगा. दिस वाई इज द अमाउंट विच इज ऑलरेडी बीन सबमिटेड इन दैट पर्टिकुलर अकाउंट. उस पे फिर 5%, ये वाई हमेशा आफ्टर t years this y is increasing. This y is not constant. This y depends on t basically. अगर पहले साल में 1 मिलियन है तो दूसरे साल में y की अमाउंट जो है वो 1 मिलियन प्लस दिस अमाउंट होगी, ऑलरेडी हिडन होगी ना. आई होप यू गेट इट, यू कैन इमेजिन इट.
सो इनिशियली जब टाइम 0 है,
हाँ,
ठीक है, तो हमारे पास ये पहली टर्म तो पूरी 0 हो जाएगी, मतलब कि बैंक के अंदर कोई पैसे नहीं है और बैंक इंटरेस्ट किसी चीज पे अप्लाई नहीं कर रहा.
डेफिनेटली.
ठीक है, और फिर उसके अंदर बस 4,000 और हमारा बस वो परसेंटेज इंक्रीज होगी
हाँ
जो
देखिए,
हमारी
जब टाइम
सैलरी.
जीरो होगा, तो यहाँ पे भी जीरो आएगा ना. देर इज नो
हाँ
इंटरेस्ट रेट, यहाँ पे भी जीरो हो जाएगा. सिर्फ
हाँ
4,000 होगा जो कि इनिशियली सबमिट हुआ है 8% ऑफ दैट सैलरी.
ठीक है.
ठीक है, दिस इज बेसिकली, थोड़ा सा इस पे यू थिंक ओवर इट. आई गिव यू टाइम, बल्कि टाइम तो खत्म हो गया. आप इसको में ये जो द नोट्स विच आई शैल अपलोड, मेरे ख्याल में अपलोड नहीं हुए हुए ऑलरेडी, मैं अपलोड कर दूंगा लेक्चर के बाद. आप इनमें से इसको रीड करें, इस प्रॉब्लम को. ठीक है, ये जो डिफरेंशियल इक्वेशन है ये सिर्फ मॉडल कर रही है जो ऑलरेडी सबमिटेड है ईच ईयर. वाई जो है वो ईच ईयर इंक्रीज हो रहा है. ठीक है, उसमें क्या इंक्रीज हो रहा है, एक तो 5% इंटरेस्ट की वजह से इंक्रीज हो रहा है, और दूसरा किसकी वजह से इंक्रीज हो रहा है, जो कंपनी जो है वो आपका सीपी फंड अकाउंट में जो आपका सैलरी का 8% डिडक्ट करके जो सबमिट कर रही है, उस सैलरी भी चेंज हो रही है हर साल. तो ये कॉन्टिन्यूस इंटरेस्ट होगा उस चीज पे, क्योंकि सीपी फंड जो आपकी कंपनी सबमिट कर रही है, डिपॉजिट कर रही है आपके सेविंग अकाउंट में, सीपी फंड अकाउंट में, वो चेंजिंग है, ठीक है, वो भी चेंज हो रहा है, वो भी इंक्रीज हो रहा है। और जो बैंक में जो इन्वेस्टमेंट आ जाती है, मसलन फर्स्ट ईयर आपके पास 4,000 है, सेकंड ईयर वो 9,000 है फॉर एग्जांपल, तो सेकंड ईयर 9,000 जो इन्वेस्टमेंट होगी उस पे 5% इंटरेस्ट होगा, ठीक है। उस 9,000 में आपका जो सीपी फंड जो कंपनी जमा करा रही है वो भी इंक्लूडेड होगा, ठीक है। सो थिंक ओवर इट, क्योंकि ये बेसिकली मल्टीपल कंटिन्यूस इंटरेस्ट हैं इस पे। एक तो कंपनी भी आपको दे रही है, ठीक है, और आपकी सैलरी भी इंक्रीज हो रही है, आपका सीपी फंड पर मंथ इंक्रीज हो रहा है, इसी तरह आपका जो बैंक आपको जो इंटरेस्ट दे रहा है वो भी इंक्रीज हो रहा है। तो दिस इज बेसिकली काइंड ऑफ मल्टीपल इंटरेस्ट प्रॉब्लम। If you have any question, you can ask me. Otherwise, we are going to stop today here.